What's up guys, it's Iman Fiaz and today's video is on June 2017 question 2 A-level paper 1. I really want to finish paper 1 and then move on to A-level paper 2, or maybe after paper 1 maybe today, tomorrow on Sunday I'll go through all the AS level questions. Depends really. And then I said I wanted to get it done by this end of December, so then I'll have almost a month to do all of the paper 2 questions and try to look at the paper 3 questions for A-level. So this question is about acidic solutions. Acidic dissociation constant Ka is given by this. We know the value of Ka is this at 25 degrees Celsius. A buffer solution to pH of this was prepared using ethanoic acid and sodium ethanoate. Concentration of ethanoic ions was this. Calculate concentration of ethanoic acid, give your answer to using different figures. Okay, so first things first, let's find out the H plus, amount of H plus ions. Well, we know to find that out, what do we use? We'll use not pH equals 10 to the power minus pH. So H plus is equal to, you're just remembering the equations and then identify, oh, they gave us a pH, we need this because we want to find out this, and you get 10 to the power minus pH, which is minus 3.87, and we get the concentration or the measure of the hydrogen ions as 10 to the power minus 3.87, 1.35 times by 10 to the power minus 4. 1.35 times by 10 to the power minus 4. Now this is going to help us. Now we can quite easily finish off the question because we know Ka is equal to this. We're trying to find the concentration of ethanoic acid, which is this bottom thing. So we just rearrange the equation. You get CH3COOH is equal to CH3COO minus H plus divided by Ka. All you've done is swap them around, or in maths terms you times it by CH3COOH, so you get CH3COOH Ka, and then divided by Ka, you get CH3COOH is equal to this divided by Ka. So now we know the concentration of ethanoic ions, which is this, is 0.136, so we can say 0.136 times by concentration of H plus ions, which is this 1.35 times by 10 to the power minus 4 divided by Ka, which is 1.74 times by 10 to the power minus 5. And we get the answer of, well, 0.136 times by 1.35 times by 10 to the power minus 4 over 1.74 times by 10 to the power minus 5, 1.06. mole per dm minus cube. 2.2. In a different buffer solution, concentration of ethanoic acid was that, and the concentration of ethanoate ions was that. A sample of sodium hydroxide 7.0 times by 10 to the power minus 3 mole sample of sodium hydroxide added to 500 centimeters cube buffer solution. Calculate the pH of the buffer solution after sodium hydroxide was added. Give your answers to 2 decimal places, and it is 6 marks. So it's going to require multiple steps, that's for sure. So what is the first step? what we're trying to find, the pH of the buffer solution after the sodium hydroxide was added. So in order to find pH, it's equal to minus log 10 of H plus ions. So we're going to need to rearrange the equation in 2.1 to find out the H plus ions. So it's going to be H plus is equal to, well, H plus is going to be equal to Ka times by ethanoic acid. Yep, so it's going to be Ka square brackets for all of them times by ethanoic acid over 3COO minus. Now we haven't done any calculation, but this is going to make, you know, the question a lot easier to solve, because we know we need to find out the concentration of H plus ions, and this is the formula now. We've rearranged it and we know what to do now. We know the value of Ka, 1.74 times by 10 to the power minus 5. So we're going to have to find out the moles of ethanoic acid after the addition. So first things first, we know the moles of ethanoic acid is moles of ethanoic acid. There we go. We know moles is equal to concentration times by volume, and if you do that for the ethanoic acid, you get the moles is equal to 0.130. Well, I got 0.13, so 0.13. Now we can work out the moles. Now we need to work out the moles of sodium ethanoate. And we get 0.0605. So usually, before I even carry on, with these 6 markers, or it's more than 4 marks, the first step in these pH or the buffer kind of questions is you need to find out the moles. So even if you don't really understand what's going on, you can easily get 2 marks, if not 1. At least it's easy to get 1 mark, if not 2, by just calculating the moles. Now we can work out the moles of CH3 after the addition of the sodium hydroxide. So what's it going to be? Well, 0.13 minus this. That's what it's going to be. Minus 7 times by 10 to the power minus 3. And also 0.0605. In this case, we're going to add 7 times by 10 to the power minus 3. We get 0.123. We get 0.066. 0.75. And there we go. We can quite easily answer the question now. We've got the the values that we need. So H plus is going to be 1.74 times by 10 to the power minus 5 square brackets, and then square brackets again, 0.123, which is the moles of CH3COOH after addition, 0.123, divided by 0.0675. So first thing we did was, well, this is not necessary, but we rearranged the equation to get H plus. We realized we've got Ka, we need to find out this, we need to find out this. So work out the moles of ethanoic acid, 0.130, moles of sodium ethanoate, 0.0605. And now we know that this sample of sodium hydroxide is added. So what we're going to do now is going to do our current moles we have minus the 7 times by 10 to the power minus 3 for one of them. And then for the C3COO minus, we're going to add 7 times by 10 to the power minus 3. We get the moles, substitute into the equation. That's simple. So find out the moles, minus the sample I did, and add the sample I did, and get the moles, substitute in the equation. And now let's find out what the value is. Times by 0.125, 0.123, 0.5, and 0.0675. That's what we're dividing by. We get 3.17 times by 10 to the power minus. Oh, it's 1.74 times by 10 to the power minus 5. So yeah, you can lose mistakes by just doing silly errors like I'm currently doing. So don't do it. It's 3.17 times by 10 to the power minus 5. And now to work out the pH, we just use this formula, this equation. pH is equal to minus log 10 of H plus. And we've done all of this to work out H plus. So it's just going to be pH equals minus log 10 of 3.17 times by 10 to the power minus 5. And hopefully you know how to do that and you calculate the minus log 10. 3.17 times by 10 to the power minus 5. And I get 4.498940. So to do decimal places, it's going to be 4.50. And that is how you do it. And that is the end of question 2. So question 2.1, pretty nice question. Rearrange the equation to find out this. And we know that H plus, concentration H plus is equal to 10 to the power minus pH. Give us pH, we get the concentration of H plus. And then substitute an equation and we get the concentration of acid. The hard part really is knowing this equation, knowing that you have to use it, and also rearranging the equation with quite ease. And then that's how you get it. And then 2.2, find out the moles of ethanoic acid, find out the moles of sodium ethanoate, subtract from the 7.00 times by 10 to the power minus 3 mole sample of sodium hydroxide, and add as well, and then use those values to find out the pH, to find out the concentration of the H plus ions, and then we can use the equation pH equals minus log 10 H plus to calculate the pH of the buffer solution, and then give the answer to 2 decimal places, and then give the answer to 2 decimal places. End of question 2.